Hi friends, I wanted to speak about mutualism. Mutualism is a population interaction where both species A and species benefit from each other. So mutualism and symbiosis is synonyms. So eating on the same table. This interaction, mutualism, confers benefits on both the interacting species. Example for this mutualism is lichens. Lichens, they present an intimate mutualistic relationship between a fungi and a photosynthesizing algae or cyanobacteria. So you can see this layer of it, a section of lichens. It shows the algal layer, and there is a fungal hyphae, microscopic hyphae. So they coexist together, and you know that lichens are also the pioneers of the plant succession. So the lichens is a combination of close combination of algae and fungi, phycobiont and mycobiont we also call it as. So this is a picture of the algae, the lichens. Lichens are of different type. The crustose lichens which stick onto the stones and you cannot peel it off. The foliose lichens which are leaf-like, and the fruticose lichens which have the fruiting bodies. Reindeer moss is one such example of fruticose lichens. Now here you can see the fruiting bodies, the cups that you can notice, apothecial cups on the lichens. So this is a fruticose lichens, where again they have a algal and fungal close association, that is phycobiont and mycobiont association. So it's a very good example for mutualism where both benefit. The algae is going to synthesize the food, and the fungi helps in fixation of nitrogen, and they also provide protection for the lichens. So mycorrhizae, this is also another mutualism where it is an association between fungi and the roots of higher plants. The fungi, that is the mycorrhizae, it helps the plant in absorption of essential nutrients from the soil, while the plant in turn provides the fungi with food, that is the energy yielding carbohydrates. So you can see the mycorrhiza here, that is in one of them it is outside of the roots, in the another the mycorrhiza is inside. Accordingly we call it as ectomycorrhiza and endomycorrhiza. Now in the roots, which has this ectomycorrhiza, you can see the fungal sheath. So this is a mutualistic association between mycorrhiza and roots of higher plant. Now mutualism is also found in plant-animal relationship. The plant needs the help of animals for pollinating their flowers and also in dispersing their seeds. Animals, obviously they have to get a reward or fees for the services that plant expects from them. So the plants provide them that source of service or fees for them. The plant offers rewards in the form of pollen and nectar for pollinators, and juicy and nutritious fruits for animals which help in the dispersal of seeds. But the mutually beneficial system should also be safeguarded against cheaters. There are certain animals that try to steal nectar without aiding in pollination. There are such types of insects too. So the plant-animal interactions often involve coevolution of the mutualist, that is the evolution of the flower and its pollinator species are closely linked with one another. So there is a coevolution of one another for their survival. So in many species of fig trees, Atihannu or Anjura, what we call it as, there is a one-to-one relationship between the pollinator species of wasp. The fig species can be pollinated only by its partner wasp species and no other species. So the female wasp, if you look into the fig fruit, it is a special type of inflorescence which we call it as hypanthodium. So initially they would be green in color. The green colored one is the receptacle. When you open it up, you find the three types of flowers: male flower, female flower, and gall flower. So now through the small opening of ostiole, the female wasp, they enter and lay their egg on the female flower, and the developing young larvae, it feeds on the seeds and it develops. The wasp simultaneously pollinates the fig inflorescence while searching for suitable egg laying sites. In return for the favor of pollination, the fig offers the wasp some of its developing seeds. It sacrifices some of its developing seeds so that at a larger scale they have more benefit or pollination brought about by this wasp. So that is how the fig, even though it loses certain seeds as food for the developing wasp, it undergoes a greater pollination by this wasp within the uh, Hypanthodium inflorescence. You can see here the wasp insect which enters through the ostiole and it lays its egg. They develop, the wasp lay its egg, and on the female flower which is initially fertile, and once they start developing the wasp insect, they feed on this ovary, and this female flower becomes sterile, which we call it as gall flower. Gall flower is a flower where the wasp has laid its egg, and later once it develops, the wasp starts roaming around and it pollinates the female flowers. So this is how there is a mutual help of the wasp insect as well as the fig fruit, and they have to co-evolve together. So this is the photograph that the textbooks prescribe for the mutual relationship between fig tree and wasp. Fig flower is pollinated by wasp, wasp laying eggs in a fig fruit. So these are the examples of it. You can see the wasp insect in the Anjura or Atti Hannu. Thank you.